Hello, I'm Justine Murphy with Vision Systems Design's Focus on Vision. There are some cool things happening in machine vision and imaging. Let's take a look. There's more to smartphone LiDAR than just advanced photography. It could also greatly enhance machine vision applications. Researchers at the Massachusetts Institute of Technology Media Lab have discovered that consumer-grade LiDAR sensors can be used for non-line-of-sight imaging, essentially seeing around corners, using inexpensive off-the-shelf hardware. Until now, such a task has only been possible in specialized optics labs with calibration and bulky equipment. The team made the discovery via motion-induced aperture sampling, their approach inspired by burst photography, which captures multiple photos in rapid succession, and synthetic aperture radar, an active remote sensing technique that uses radar pulses to produce high-resolution images. The technique combines faint light signals bouncing off nearby objects, like walls and floors, ultimately revealing what's just out of view. In a series of tests, the method was most effective with reflective objects, but the team says it has also produced usable signal quality on diffuse surfaces. The technique could potentially be used in plug-and-play devices for broader real-world applications, including robots navigating complex manufacturing facilities and autonomous vehicles sensing obstacles around blind corners. Industrial generative AI company Cignal Defense is moving beyond its core work in homeland security and into the broader defense and industrial-based manufacturing sector via machine vision AI. Signal Engine, which the Pennsylvania-based company says is a training platform for intelligent machines, provides voxel tensor physics and rendering, the computational modeling of 3D physical systems that are designed specifically for machine vision AI. The new system also overcomes some critical national security challenges in AI, including cold start, essentially a lack of existing data when creating a model, and long tail, which involves unexpected scenarios that are difficult for AI models to predict. Signal developers say their new platform could be used for applications like autonomous ground vehicles, unmanned aerial systems, and undersea sensing. The team is also exploring applications including acoustic and other defense sensing. Robotics developers continue to push for more intelligent, autonomous systems, but they say there are numerous challenges to overcome. Among them, functional safety risks in human-robot interactions and ensuring predictable behavior. In a new global survey of 1,000 robotics developers conducted by QNX Research, a division of BlackBerry Limited that specializes in foundational software, has found that nearly 90% of respondents expect physical AI, robotic systems that interact directly with the real world instead of just digital software, will be crucial for their future work. In its Inside the Robot Architecture Benchmark report, exploring the current gap between existing capabilities and future robotic system developments, QNX says that 1 in 3 of those surveys identified software architecture and integration as the main bottleneck in creating more secure and scalable software foundations that will ultimately be needed for robots in real-world environments like factories. Overall, the QNX report found respondents remain optimistic that stronger software systems will push AI-enabled robots to better perceive, reason, and act autonomously. Well, that's it for this edition of Focus on Vision. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit vision-systems.com for the most up-to-date, interesting, and exciting news impacting the machine vision and imaging industry.